BCPS families and students. Today we're going to work on multiplying and dividing powers of 10. This is from the Grade 5 Bridges Week 9 lessons. The objective this week is that students will use what they know about powers of 10 and place value to multiply and divide decimals and whole numbers. Just like I say every week, grab that scrap paper and a pencil and maybe something that you can take pictures with so that you can take pictures of some problems and go back to them after this video. Today's number is 64. How many ways can you show 64 using expressions? We've been doing a lot with expressions the last couple weeks. Then write a story problem to go with one of your expressions to show 64. I bet you can find somebody in your house that can solve that expression. We have several vocabulary words we want to review in order to prepare us for this week's lessons. The first one is exponent, a number or symbol that indicates the power to which the base number is raised. As you can see here, 3 to the second power, the 2 is the exponent, equals 3 times 3. And 4 to the third power, 3 is the exponent, equals 4 times 4 times 4. Another vocabulary word we would like to review is expanded form. We've been working on expanded form all year. It is a way to write a number that shows the place value of each digit. We have the example 349 written in expanded form equals 300 plus 40 plus 9. And last, we have exponential form, a way to write a number that shows the place value of each digit using exponent. So over to the right, we have 10 to the first power equals 10, 10 to the second power equals 10 times 10, which also equals 100, 10 to the third power, which equals 10 times 10 times 10, which equals 1,000, and so on. Each number in the pattern above is 10 times as much as the number before. Now we're going to look at different forms of powers of 10. You can look in the first line, we have standard form, which is 10, factor form, which is 10, exponential form, which is 10 to the first power. In the next row, we have 100, which is standard form. So we know that 10 times 10 is the factor form, and then we have 10 to the second power. So let's look at this third row. We have 10 times 10 times 10. Well, we know that that's going to be 10 to the third power, giving us in standard form 1,000. Okay, in the next column, we know that it's 10,000 or 10 to the fourth. So in factor form, it would be 10 times 10 times 10 times 10. Then we have 100,000, which is 10 times 10 times 10 times 10 times 10, which is this equivalent to 10 to the fifth power. And finally, we have 10 to the sixth power, which gives us 1,000,000, which equals 10 times 10 times 10 times 10 times 10 times 10. Now we're going to take numbers in standard form and put them in expanded form and exponential form. Let's look at the first row. We have 365 and 2500ths. Well, when we take it to and put it in expanded form, we have 3 times 100 because the 3 is in the hundreds place, plus 6 times 10 because 6 is in the tens place, plus 5 times 1 because 5 is in the ones place, plus 2 times 1/10 because 2 is in the tenths place, plus 5 times 100ths because 5 is in the hundredths place. Now we're just taking those powers of 10 and making them exponents. So we have 3 times 10 to the second power, plus 6 times 10 to the first power, plus 5 times 1, plus 2 times 10 to the negative first power, because we're now dealing with decimals, plus 5 times 10 to the negative second power. Let's look at one and do it step by step. We have this number 2,856 and 42 hundredths. Well, to write it in expanded form, we're going to start with 2 times 1,000 plus 8 times 100 plus 5 times 10 plus 6 times 1 plus 4 times 1/10 plus 2 times 1/100. Now remember, we're going to take those powers of tens and make them exponents, giving us 2 times 10 to the third power, plus 8 times 10 to the second power, plus 5 times 10, or 10 to the first power, plus 6 times 1, plus 4 times 10 to the negative first power, plus 2 times 10 to the negative second power. Now we're going to use what we've learned so far to help us multiply a whole number by a power of 10. We're going to do the problem 36 times 10 to the second power. First, we're going to rewrite the expression to an equivalent expression, representing the number of times 10 is multiplied by itself based on the exponent. So we know that we have 10 to the second power, so we're going to take 36 and multiply it by 10 times 10. Then we're going to multiply. We know that 10 times 10 is equivalent to 100, so it's the same thing as 36 times 100, which then gives us a product of 3,600. I want you to take note, multiplying a number by a power of 10 results in the number shifting to the left. So since the problem is multiplying by 10 to the power of 2, the number must shift 2 places to the left. So the 3 will shift to the thousands. The 6 will shift to the hundreds. And then you'll place zeros as placeholders. You're probably starting to see a lot of patterns. So for instance, 57 times 10 to the first power is 57 times 10, which equals 570. 57 times 10 to the second power is 57 times 10 times 10, which gives you a product of 5,700. So 57 times 10 to the third power would be 57 times 10 times 10 times 10, which is equivalent to 1,000, which would give you 57,000. And finally, 57 times 10 to the fourth power would give you 57 times 10 times 10 times 10 times 10, which is equivalent to 570,000. Multiplying a decimal by a power of 10 is similar to multiplying a whole number by a power of 10. They're the same steps. We have step 1, which is rewrite the expression to an equivalent expression representing the number of times 10 is multiplied by itself based on the exponent. Our exponent is 3 this time, so we're going to have 4 and 3/10 times 10 times 10 times 10. Now we're just going to go ahead to step 2, which is multiplying 4 and 3/10 times 1,000, which gives us 4,300. With decimals, we're doing the same thing. We are shifting to the left in place value. So, since the problem is multiplying by 10 to the power of 3, we're going to take our 4 and 3/10 and we're going to shift them 3 places to the left. So the 4 is going to go to the thousand place. The 3 is going to go to the hundredths place, and zeros to hold your place. Let's look at the patterns that are similar to the ones that we saw when we were multiplying whole numbers by powers of 10. We have 4 and 5/10 times 10 to the first power, which is equivalent to 4 and 5/10 times 10, which equals 45. 4 and 5/10 times 10 to the second power, which is equivalent to 4 and 5/10 times 10 times 10, which is equivalent to 450. Now we have 4 and 5/10 times 10 to the third power, which equals 4 and 5/10 times 10 times 10 times 10, which is equivalent to 4,500. And finally, we have 4 and 5/10 times 10 to the fourth power, which is 4 and 5/10 times 10 times 10 times 10 times 10, which is equivalent to 45,000. When multiplying a number by a power of 10, it results in the number shifting to the left. A similar shift in the other direction occurs when you divide a number by a power of 10. When you divide by 10, the numbers shift to the right in place value. You get an answer that is smaller than the number that you started with. Each place in a number is like a power of 10. So for instance, this first problem, 64,000 divided by 10 to the first power, dividing by 10 is just shifting one place to the right. So I would write my 64,000, and I'm going to shift one place to the right for each number. So our quotient would be 6,400. For the problem 5,700 divided by 10 to the third power, it's just like doing 5,700 divided by 1,000. Since I have 3 zeros, I'm going to take my decimal point and do 3 jumps. So my answer would be 5 7/10. When a decimal number is divided by a power of 10, this results in the number shifting to the left, the number of places equal to the number of zeros in the divisor. Notice that the decimal can be seen to be shifting to the left. So we have our first problem, which is 2 7/10 divided by 10 to the first power, which is equivalent to 2 7/10 divided by 10. And we have 1 0. So our decimal place jumps once to the left, giving us a quotient of 27 hundredths. Now our second one, which is 2 7/10 divided by 10 to the second power, is equivalent to 2 7/10 divided by 10 times 10, which is equivalent to 2 7/10 divided by 100. You can see that there are 2 zeros, so this time we're going to make 2 jumps to the left. Okay, which would mean that we would put our decimal point here. See how we have this open space? We'll have to put a 0 there to hold the place. So our quotient will be, you can't really see that decimal, sorry, 27 thousandths. We follow a similar process for 2 7/10 divided by 10 to the third power. We know that 2 7/10 divided by 10 times 10 times 10 is equivalent to 2 7/10 divided by 1,000, which is now going to mean that we're going to have to make 3 jumps because we have 3 zeros. So I'm going to write down here so we have a little more room. My decimal point was in between the 2 and the 7, so it's going to make 3 jumps. 1, 2, 3. Putting my decimal point right here, I will have to put 2 zeros to hold the place. So my quotient, just written a little bit nicer, is 27 10,000ths. Now, bringing all that knowledge together, we're going to look at the pattern. Our first problem is 45 divided by 100, giving us a quotient of 4,500. Following this pattern, we have 45 divided by 1/10, which is going to give us a quotient of 450. 45 divided by 1, 45. 45 divided by 10 to the first power, 4 5/10. And 45 divided by 10 to the second power, 45 hundredths. Now it's time for the try it. You can either use the scrap paper that you got at the beginning of this video and show it to your teacher, or you can find these resources in your course in Schoology. You're going to multiply on the left-hand side and divide. Then I want you to think to yourself, what patterns do you notice in the equations? A little more practice. There are 6 problems on the top, so you will be dividing or multiplying by a power of 10. And then we have a word problem. Ramon bought erasers shaped like animals to give away at family night at his school. Each eraser cost 10 cents. If he spent $25.60, how many erasers did he buy? Write a division equation to represent this situation and then solve it. Now it's time to show us what you know. Remember to talk to your teacher about how she or he would like you to submit your work. We have 8 problems for you to do. Then I want you to answer, compare what happens to the quotient when you divide by 10 and by 100. And after you answer that, compare what happens to the quotient when you divide by 10 and by 20. And finally, Carrie and Val were solving the following problem. $12.55 divided by 5. Carrie wrote $25.10 as her answer. Val wrote $2.51. Who is right, and how do you know? Have a great day!